and welcome. This is Raul. This time around, we're going to be looking at the Doepfer module called the dual sample and hold. That's the sort of thin one here in the center. We're going to be talking briefly about sort of the overview of the features of it, what these ports are intended for, and then we're going to move right into a demonstration of what this module can do for you and how you can use it. To start out with, we're going to talk about what a sample and hold actually does. So to do that, we're going to have to talk about what these ports are. So the first one, trigger in, is going to tell the sample and hold how often to sample whatever it is that's coming in at the sample in. And then it takes that information that it got at the trigger moment and creates a voltage, and then you can send it out to your VCO or to your filter. But it basically is taking a snapshot at whatever frequency you tell it with your LFO, and generally a square wave to be more specific. And this will make more sense once we get into the demo portion of it. And with that voltage, you can get some fairly interesting results. So, with that little introduction, we're going to just jump right in to the demonstration. I hope nobody minds. So let's start out. We're going to actually start out with what in general people understand as a sample and hold. So if you have an older synthesizer, or maybe you have a digital synthesizer that happens to have some kind of sample and hold type function in it, this next little portion is going to be sort of what a standard, so to speak, sample and hold is. And that's going to be starting out with white noise right over here, fed in to the sample in of the sample and hold. So we're going to patch that in there. And then the most important thing that we're going to need is a square wave. This square wave is going to be our best friend here shortly. Let me make sure it's in the low frequency range. And then I'm going to patch into my square wave. And then I'm going to patch that right into my trigger in. And that's going to tell it how often it needs to sample. So it's going to be sampling the random noise going in at whatever frequency I set here on my LFO. So here we go. Patching it. And it's a little bit difficult to see, but you can see the lights start to move here. And you can see they're kind of flickering a little bit. So it is taking a voltage in to the sample in. And it's taking sort of a snapshot of it, and then it's actually outputting a voltage. We don't hear it yet because we're not patching anything out to anything else, but we will hear shortly. I just wanted to talk about what's actually happening here, and then sort of visually see what's happening before we hear it. So you can see that there's a sample, there's a sample, there's a sample, there's another sample. And you may notice here that there's two lights here. Well, it may be a little difficult to see, but there's actually a plus symbol and a minus symbol right underneath there. And these help you determine whether the voltage being output from this module is actually a positive voltage or a negative voltage. And we'll hear exactly what the difference is between those two here shortly. But for now, I just wanted you to see that right now with the frequency at, let's see, about 2 o'clock, if I bring it up, you should start to see my lights sort of go a little bit faster and faster and faster, all the way until I get to there. And then, of course, I can bring it all the way down. And then, of course, my lights move down to a crawl. Or I can go all the way up, depending on my mood. So there we go. That's our sort of basic sample and hold type patch. And then now we're going to actually take the output of here and go into our oscillator. I'm going to patch into CV2 right there, and I'm going to bring CV2 all the way down so we can hear the dry signal of the VCO before we start to add sample and hold to it. But you can see that our pace is relatively quick on the LFO, and it is patched into CV1. So I'm going to pick a saw wave, and I'm going to go into input 1 of my mixer. So here is our dry VCO signal. Once I patch that, and once I patch this. There we go. That is our dry VCO signal. And now I'm going to bring in the sample and hold. Here we go. So that is a basic sample and hold type sound when it's sent to a pitch input of a VCO. And then if I bring my frequency down a little bit, you can actually hear it slow down. And I can actually go way, way slow if I want to as well. So just depending on what kind of mood you're in or what kind of song you're wanting to write, this is how you can vary it by adjusting the frequency of your LFO. And then if you go all the way to the top, let's say that's not quite fast enough. I want faster. Luckily, the LFO has a middle mode. So if I flip over to middle mode, you notice it went very, very fast here. Well, that's because now I'm in middle mode, but I'm actually at the top of the middle mode. And if I bring it back down, see all the way back here is about where we left off in middle mode. So I can actually go a little bit faster than I could a moment ago. So then I can actually get a faster type sample and hold sound if I want. So there you go. That is your basic sample and hold type patch. At least going into an oscillator so far. Now, since we have white noise going in there, and it is sampling that, it basically translates to random notes, because the white noise, if you know a little bit about white noise, it's actually all the frequencies found in the entire spectrum. So when it samples that, since it's doing it at a rate that's fairly fast, it's just sort of taking small snapshots of the noise, and that eventually translates to a random voltage which comes out of here, and then you get random notes. Now if you wanted to make them sort of translate to something you could use in, say, a diatonic scale, you would need something called a quantizer, which we may talk about in the future sometime, to translate the voltages coming out from here into voltages that are set to a specific scale. Okay, so this is our sample and hold sound. Now, the one other thing I wanted to show you about this is that in our noise module over here, we actually have two outputs. We have a white output right there, and then we have a colored output right here. So, if you watch the tutorial that we had a while back on the random noise module over here. We talked briefly about the two different types of noise. There's blue noise, which is the high frequency noise, and there's red noise, which is low frequency noise. So if I patch into my colored output, we can actually adjust the amount of low frequency and high frequency noise. So, enough of me talking about it though, let's actually hear what it sounds like. See, as I pull my sample out, it kind of stops at the last voltage that it had. Now let's patch into the colored noise now and see how that changes our sample and hold. Okay, so now I can actually control the sample and hold by adding more high frequency noise, or I can bring down my low frequency noise. And you can hear it there changing a little bit. So you can get a little bit of variety with your sample and hold if you use colored noise. So that's with red in the very low position and blue in the high position. Now if I want to, I can vary that and maybe bring down the blue noise. Bring up my red noise component. Get a slightly different flavor of sample and hold yet again. And I could also bring both all the way to here. I don't know exactly what this translates to, but I just can hear that it sounds different to me. And something else I can do as well with the noise is I can adjust the rate and the level. Of course, this is not for these up here. These two are actually here, but we can actually use this here in a moment. I just wanted to talk about those before I jump right in. So we can hear now what's going on with the blue and the red noise. And then I'm getting a different type flavor to my sample and hold, because it's basically modifying the signal going into the sample in. Okay, so I'm going to unpatch this, and then let's hear what the random output sounds like. Now here you have yet another way that you can control the output. Like when we were dealing with colored noise here, we had these two controls. Well, these two controls still allow a change to occur at the random output. And if you've read the manual, then you already know this, but I'm just kind of reviewing it a little bit. So if I adjust the blue, adjust the red, I actually get a slightly different flavor going out from my random output. The more I bring the rate towards the 0 over here, the faster the noise will change. I can also change the level of the noise going out. And there you can hear it almost kind of sort of not quite moving as much. Until it is audible again. And you notice that here there's also two red lights. One of them labeled with a plus symbol. It might be hard to see with the cable there. But there's a plus symbol and then a minus symbol. This also will indicate to you if the output is positive or negative. So if I bring it over here, you should start to see the red lights sort of fluctuate, or alternate I should say, back and forth. And you'll notice here, as soon as you start to adjust the red frequency combining with the blue frequency, the lights change in a slightly different pattern. And then we have sort of a concentration more of just high notes. So depending on what type of sample and hold type sound you want, you can get it. by mixing two different flavors of noise, or as we saw before, just a regular colored noise with blue and red, or you can adjust your sample and hold by just using white noise, which is the standard type sample and hold sound. Okay, so we've heard a little bit about what happens when you patch noise into the pitch of an oscillator, but let's hear what happens when you patch the sample and hold into a filter.